So, question 10a, and we've got we're given a sketch of a complex region down below, or really it's an arc, and we've got to write some equations without using x as the real part and y as the imaginary. Now, typically this historically is done to stop, say we've got a sort of simple little graph line like this. We could say, well, look, y is 1 minus x, and then we just convert y to the imaginary part of z, x to the imaginary part of z, and we're good to go. We just got to put a domain restriction on it as well there. So typically that's what this is all about here. And when we look at this, we're actually not told that this is part of a circle. There's a little dot, 1 plus 2i here, so which is a little bit smaller than the little fellas out here. So is this part of the region as well, or what? Normally, like this question, they'd say this is an arc of a circle or something like that to give us a bit of clue. However, let's assume that it is part of a circle. It's a little bit rich to make that assumption because in this very same paper, I've forgotten which question, but later on we'll come across it. We're actually given a function that looks like a circle and we have to prove that it's not. So in the same exam, to just give us an arc like this that looks like a circle and we have to assume it. Anyway, that's why we've got this kind of face up here, because we're all a bit confused. Anyway, let's do it. So if we assume this is the center of the circle and this is the arc, then typically we're just going to say the distance of z from the center, 1 plus 2i, is equal to 2. It's not an inequality, it's just equal to 2, so we just get the arc there. And then we just restrict the real part to be greater than 0, so that will take us to the right of the imaginary axis. And the imaginary part of z is greater than 2, which will keep us above here. But then I got a bit nervous and looked at these and thought, oh, maybe I can't even use them here for sort of straight line inequalities. So an alternative way would be to, let's just grab a circle here for a minute. If I just bung in the whole circle here, there we go. So basically we've got this whole circle and we're just trying to restrict it to that part. We could put in a couple of rays, one up through there, and maybe one across there or something, and then say the argument of z's got to be somewhere between here and here. But then when you look at it, you think, well, so long as the center of this kind of little region that I choose is somewhere inside the circle, we can't go wrong. So maybe if I erase that out the way and instead choose an arc up there and an arc up there, so then I can restrict. If I transform z, so like here an alternative one, we start off with exactly the same as up here, but then we say, right, the argument of z from from 2i, from this point, has to be between 0 and pi by 2. So between 0, which is here, and pi by 2, which is up here. It's a bit easier than doing it through the actual kind of fake center of the circle there. Another way that we could do this is to, let's get rid of all of that stuff, and we could just put a straight line through here instead, through the points. Let me see if I can get one about right. Basically, that'll do. We could say that we just want, we've got to be closer to this region up here than this region down here. So we could work out a couple of points and write it as we have down the bottom here. So an easy way of doing that is just to count a few squares. So here we're going across 3 here, and then we're going up from 2 to this point here. Now, just bearing in mind this is 1 and this is 2, then the distance from 2, this point here, has got to be 2 plus root 3. So if we then take this L shape and rotate it around so that we're coming down here and over to about here, then this point has got to be something like, where is it? We're 3 across, but then we've got to come back root 3. So it'd be 3 minus root 3, and then we're starting at 2 up and we end up 3 down, so it would be a minus I. And then translate this over so that we've got another L up here to find the second point. And this one will be now 3 plus root 3 across and 5i up. And then we could just say, so we want the intersection of the circle, and then this region where z is, the distance of z from this point is less than or equal to the distance of z from this point. We're using include to get the sort of 2 points in at either end. So a couple of ways of doing that one. Let's move on to part B. And sketch the locus of this equation in the Argand diagram below. We look at this and we think, what's going on here? And I think for 3 marks, my first instinct would be to get a pretty sad face on and come back and do this one later. However, with insight, it's not too bad. If we read this as the distance of z from the point -2, which is over here, is equal to the distance of z from I, which is here, plus √5. And we think, so z has got to be sort of √5 further away from this point than from this point. And we think, oh, how does that help? Now, it helps if you spot that the distance between these 2 points is 2 across and 1 up. So if we go 2 squared plus 1 squared square rooted, we get √5. And so then that's saying we've got to be √5 more away from 2 than this point. So basically anywhere on this line that goes through these 2 points and the ray extends up here to the sort of, following the line of these 2 points is going to satisfy it. In between here, the distance is going to be pretty much, or the sum of these two is going to be √5. And over this way, we're always going to be closer to the -2 rather than I. So that's not going to work. However, pretty tricky. The calculator would have helped a little bit if you had the specialist. Here we go. File, open my complex number reactivity. So if I open up this one and sort of duck into this little strip here, which looks kind of like the one that we want, and I'm going to tap resize, we could set it up so we basically want, let's get rid of everything on the inside here. The distance of z from -2 is equal to the distance of z from plus I, wasn't it, here? So if we go plus, and then I'll use the shift dot to get in, that was from positive I, so we need a negative there, plus √5, so plus the square root of 5. And then we keep our fingers crossed and see what happens. So I'm going to hit execute and ClassPad chunders through the lines, and we end up with the equation y is equal to ½ x plus 1 out of this. And of course, that's the equation of this line here, but there are no bounds on it. And if you actually had the time to check, you'd realize if you substitute in a point such as -2 or -1 plus a ½ I or -4 minus I, then it actually doesn't satisfy this inequality. So even using the sort of calculator to help us out here, then it's not really doing a lot. So for 3 marks here, it's a pretty ugly question. But here's our solution. Yep.